Hi, today we're going to talk about multiplying powers with the same base. So let's get your name on the top of the paper so we can always keep track of your work. All right, so in our first example that they give us, they say, what is each expression written as a single power? So in order to do this, we have to remember what the rule is anyways. So let's write it at the top of our paper. The rule is a to the m times a to the n is equal to a to the m plus n. There you go. So if you multiply both of the bases, you add the exponents together. That's what we're doing. So we see this first example, and they're telling us about how I have 3 to the 4th power, 3 to the 2nd power, and 3 to the cubed 3rd power. The reason that this works is easily shown if we expand what's going on in this multiplication problem. So 3 to the 4th power, how many 3's is that? 4 of them. And then 3 squared is how many more 3's? 2 of them. And then 3 cubed is another 3 of them. So altogether, that means we have 1, 2, 3, 4, 5, 6, 7, 8, 9 3's, or 3 to the 9th power. But you don't want to have to draw all of that out every time. If you have to remember what the rule is, yeah, you can draw it out and that'll help you. But if you have really big numbers, you don't want to have to expand it. So we remember, hey, I know I can just add the exponents together and that will work. 4 plus 2 is 6, 6 plus 3 is 9. And there you go, it's done. Let's look at example B. In example B, I have 11 to the negative 3 times 11 to the 4th times 11 to the negative 5. Okay, so we're going to use our same rule. I'm multiplying the bases together, so that means I can take these exponents and just add them straight across as they showed right here on your paper. And then you can say, oh, negative 3 plus 4 is 1. And then 1 minus 5 is negative 4. Sorry, I had a brain moment. And there you go, negative 4. Let's look at example C. Now in example C, there's fractions. And the rules do not change for the fractions. They just make you nervous because most people don't love fractions, even though they should. So the base is the same. The base is a 2. And where we're multiplying these bases, we're going to add these fractions together. So in case you're just not confident in your fraction manipulating skills, let's go find your calculator real quick. If you have an Nspire calculator, did you know that these calculators will do your addition for you of fractions? So let's see how that looks. If you push Control Divide, hey, it brings up a fraction right there for you. Our first fraction was 1/5. 1, arrow down, 5. If you arrow to the right, so your blinker is full size again, but you must arrow over, then push plus and Control Divide again, so another fraction will appear, and put in 3, arrow down, and 5. Push enter, and 4/5 appears on your screen. So it will combine your fractions for you, it will reduce them for you, and just help you to be able to move a little bit more swiftly through these problems so that they don't have to be the headache that people associate usually with them. All right, so now let's look at another problem. Let's talk about the simplified form of scientific notation. So this problem is going to ask us to multiply two sets of atoms, molecules, together, and there's so many of those molecules in just one speck of mixture of compound. That's the word I'm looking for, is compound. So to get the total, we're going to put coefficients with coefficients. So this 1.8 is treated like a coefficient. And this 2.7 is also treated like a coefficient. So we're going to do regular multiplication for the coefficients. And then we're going to do exponential rules for the tens with their exponents. All right, let's see how this works in our problem. So we see that they put the two coefficients together and are multiplying them. And here are my tens with their exponents, multiplying those. So 1.8 times 2.7, yes, in your calculator, if you check it, you should get 4.86. And then using our exponential rule, we're going to add the 11 and the 8, since the tens, the base, is multiplying. As a result, our final answer will become, written in scientific notation, 4.86 times 10 to the 19th power. So those are frequently very scary, but they don't have to be, and I hope that they won't be for you anymore. Let's go do some examples together. All right, problem number 1. I have a to the second times a to the third, so that becomes a to the 2 plus 3, and we finish it off with, that's right, a to the 5th power. Done. Love that. So easy. Let's look at number 4 right below it. Coefficients work with coefficients, and they behave just like normal. So this is 8 times 6. And then p to the 5 plus 4. Which results, 8 times 6 is 48, p to the 9th power. Good job. Let's check out number 7. Here I have more than 2 pieces, but the rules have not changed. So this is h to the 5 plus 2 plus 10. And as a result, this is h to the, 17th. Great. Let's look at number 10. Okay, in this problem, we've got 2 different types of variables. I have a y and a z. So in number 4, we saw how coefficients work with coefficients and variables work with variables. Very similarly, the like variables have to go together. So y works with y, and z works with z. So this becomes y to the 3 plus 2 and z to the 13 plus a negative 6. Final answer, y to the 5th power, z to the, what is 13 plus a negative 6? 7. There you go. Let's check out number 13. See if you can do it on your own. I'll wait for you. They tried to trip you up in this problem. Did you fall for it? I hope not. There's only 2 m's. Negative 6 plus 3. And then there's an n just sitting there quietly on its own. So the result is m to the negative 3, n to the negative 2. And that's it. Okay, I want you to see if you can tackle the other problems in this section, numbers 2 through 15. If you get stuck or if you need me to check it, I'll be ready to help you. Pause the video. Let's look at number 16. Number 16, again, we have our scientific notation. So let's see how to work with that. Coefficients work with coefficients. Bases and exponents work with bases and exponents. So this becomes 4 times 2 times 10 to the 3 plus 5. What does that simplify to become? Well, 4 times 2 is 8 times 10 to the 3 plus 5 is 8. And that's it. 8 times 10 to the 8th power. Let's check out number 19 right below it. Coefficient works with coefficient. Base with exponent works with base with exponent. So 8 times 3 times 10 to the 9 plus negative 5. Eight times 3, 24, times 10 to the 4th, and we're done. Okay, it's your turn. I want you to try to do the other 4 problems in that section, 17 through 21, and pause the video. If you get stuck and need some help, let me know. All right, number 22. People get nervous whenever they see word problems, and you shouldn't have to get nervous. Let's see if we can figure this out together without too much stress or worry. So it tells us that the distance light travels in 1 year, a light year, not Buzz Lightyear, but like a legit light year, is about 5.87 times 10 to the 12th miles. That's really long. A star called Proxima Centauri, is 4.8 light years away from Earth. So about how many miles from Earth is this star? Oh, okay. So we know this is how many miles the light can travel in 1 year, but it actually took 4.2 years to get here. What do we have to do? Add, subtract, multiply, or divide? Multiply. Good. Now, what are we going to multiply? We don't have a lot to choose from, so that should narrow our options. What are we going to multiply? 5.87 times 10 to the 12th and 4.2. I'm going to write 4.2 first, just because it's a smaller term. Our brains like seeing the smaller things come first, but truthfully, it doesn't really matter. All right, so coefficients go with coefficients, and bases with exponents go with bases with exponents. This 4.2, is that a coefficient or a base with an exponent? Yeah, it's just a coefficient. So let's multiply 4.2 times 5.87 in your calculator. What do you get? I'll wait for you. Did you get 24.654? I hope so. Let's finish this off. Do I have another base with an exponent to work with? No, I don't. So this is just times 10 to the 12th. So if you remember the rules from your science class about working with significant figures, then truthfully, this should be rewritten so that there is only one digit to the left of the decimal space. So it would be 2.4654 times 10. And when we moved it over, we're going to add one number to this exponent. So 12 plus 1 makes 13. Truthfully, that is the full, most correct answer that I can give you there right now. All right, I want you to try to do number 23. Pause the video and see what you can do. All right, welcome back. Let's work through this last section of this handout together. Truthfully, I want to do this middle three, 25, 28, and 31. Let's do those together, and then you will have the happy task of finishing it off with the other 6. So I think here in problem 25, there's a typo. This says 8 to the 6th times 8 to the 5th, and then it has a giant 5. I don't think that's supposed to be there, which is why I wanted to do this problem with you. So if this was not here at all, what would be in this box? 8 to the 11. How did I get 11? 6 plus 5 makes 11. That's what would go in that box. There you go. Let's look at number 28. Okay, so we need to determine what plus 2/5 equals 4/5. Well, if you don't know, couldn't you subtract? 4/5 minus 2/5, and you have a calculator and a wonderful brain. What do you get? Yeah, if you got 2/5 back, then you did it correctly. And this would go to that box right there. All right, last problem. N to the 5th times n to the 17th. So here I think we have another typo. That is not supposed to be there at all. times n to something else. And here we have another typo. I believe this is supposed to be n to the 13th. Again, this is why I wanted to do these specific 3 problems with you. All right, so let's rewrite it so we can even see it. This is a mess. N to the 5th times n to the 17 times n to the, we don't know, will make n to the 13. How would we simplify this? Well, let's start by adding these 2 exponents together. 5 plus 17 is 22 times n to the unknown box equals n to the 13. So just like we did in number 28, let's subtract and see what we get. 13 minus 22. What did you get? -9? Great. And this is what goes right there in that box. You could also say into that box. All right, your turn. I want you to try those other 6 on this paper, and if you get stuck, let me know. I'll do my best to help you.